The US Air Force has been experimenting with drones for a few decades now, and although these unmanned vehicles have been mostly used for reconnaissance roles, the military has recently come up with more powerful and cheaper vehicles that can also be used in combat. The Valkyrie drone is one of them. Designed to be the autonomous wingman of F-22 and F-35 aircraft, this drone can also launch its own set of unmanned devices to further assist in war zones. Coupled with an Altius 600 mini drone launched from its weapons bay, several experts claim that the Valkyrie stealth drone is the first step into a new age of combat and advanced warfare. The first unmanned aerial vehicles, or UAVs, developed by the military were used for reconnaissance roles. They successfully gathered intelligence from the enemy without risking soldiers' lives or igniting diplomatic issues with nations that were being spied on. The drones have changed in weight, dimensions, and usage over time. In combination with remotely piloted aircraft, or RPA vehicles, drones have been tasked with gathering intelligence on a designated target before launching a devastating airstrike. One such example is the General Atomics Predator drone, which launches lethal air-to-surface Hellfire missiles and has been in service since the late 1990s. During its service, it has seen combat all over the world, and especially in the recent American interventions in the Middle East. But the United States Air Force has been looking for a new type of drone that can actively cooperate with manned aircraft during operations. As part of the low-cost attritable strike demonstrator program, the Air Force partnered with numerous tech companies to develop an attritable drone, a term that, according to Defense News magazine, quote, the military uses for an asset that can be reused but is cheap enough that a commander would expect and be comfortable with a certain amount of losses while in combat. In partnership with Kratos Defense and Security Solutions, the Air Force settled for the XQ-58A Valkyrie, an experimental stealthy unmanned combat aerial vehicle. This loyal wingman-style drone was designed to assist and escort F-22 and F-35 aircraft during combat missions and can carry weapons, fire them, and deploy surveillance systems. The Valkyrie is controlled by a parent aircraft to successfully scout, gather intelligence, find objectives, and attack enemy air and ground assets. Most importantly, Valkyrie features stealth technology thanks to its innovative airframe design. It features a trapezoidal fuselage, a trined engine reminiscent of the legendary SR-71 Blackbird, V-tail, and an S-shaped air intake. Valkyrie has a wingspan of 22 feet and a length of approximately 28 feet. It can reach a maximum speed of 652 miles per hour and an estimated range of 2,400 miles. When it comes to equipment, this drone can carry up to 8 weapons split into 2 weapons bays. Valkyrie can attack with precision-guided joint direct attack munitions or small-diameter bombs. In addition to its impressive capabilities, the XQ-58A Valkyrie is indeed attritable, as Kratos has estimated that the cost of each drone is valued at $2 million per copy. According to the US Air Force, this is considered cheap compared to losing an F-22 or F-35 in combat. During testing, the Valkyrie lived up to its name when it ruled the skies and achieved the expected statistics. After escorting the US Air Force's top aircraft, the F-22 and F-35 proved that Valkyrie has everything that's needed to become a loyal wingman, and Kratos and Air Force officials turned to the next step of the program, giving the unmanned Valkyrie the capability to launch additional drones from its weapon bay. The drone carried a software package called Gateway 1, which allowed the communication between the incompatible machine languages of the 2 aircraft. Because of this, the Valkyrie is also known in the Air Force as Attritable 1. The Valkyrie also showed outstanding performance when flying in formation with the 2 American aircraft. This led the US Air Force to consider buying between 20 and 30 Valkyrie drones for additional testing. Steve Fendley, the president of Kratos' Unmanned Systems Division, said to the press that, quote, I am extremely proud of our development, production, and test teams who continue to deliver successful results in record time on our comprehensive system-level efforts, rare within the aerospace and defense industry. The successful tryouts paved the way for a 6th and last test using a new weapon system. Thus came the Altius 600, a small tube-launched autonomous drone and the precursor of a new era of warfare. During Valkyrie's 6th test flight at Yuma Proving Ground, Arizona on March 26, 2021, witnesses were astonished when they saw Valkyrie releasing an LTS-600 from its payload bay. LTS-600 was built by Area 1, a Georgia-based company focused on UAV systems. Area 1 describes it as an autonomous tube-launched UAS, or air-launched effects ALE, that is, quote, delivered as all-up rounds and available on demand and operational within minutes. It also supports multi-domain operation systems that can be launched from the air, sea, and ground from systems like the Common Launch Tube, Pneumatically Integrated Launch System, and other launch systems. The device has been successfully launched from AC-130s, UH-60 helicopters, ground vehicles, and watercraft of all sorts. Once launched, Area 1 has specified that LTS-600 has significant endurance and an approximate range of more than 4 hours and 276 miles per hour. The small drone weighs 27 pounds, including a payload of up to 6 pounds stored in its nose. It can be used to counter UAVs, electronic warfare, reconnaissance, and intelligence scenarios. Kratos and Area 1 worked with the Air Force to develop a special carriage that allowed Valkyrie to launch the drone. And the US Air Force is planning to buy over 100 Valkyrie drones for additional upgrades and tests. Military expert Chris Osborne has said that, quote, launching drones from the cockpit of a manned 5th-generation stealth jet and conducting many drone attacks from Valkyrie drones themselves introduces a new sphere of tactical possibilities. A new age of warfare may come sooner than expected. Valkyrie can provide an extended range to manned aircraft for conducting high-risk operations in areas where soldiers and pilots can easily be threatened. The drone can also be extremely useful for testing enemy air defenses and areas with high-security surveillance systems where humans can be easily detected. Osborne has also reported that programming Valkyrie to fight on its own is a game-changer in itself, but launching many drone attacks from it and keeping it safe paves the way for the future of warfare, as it can construct a layered kind of mesh network extending targeting reach and combat scope. More importantly, if controlled by military personnel from remote stations, Valkyrie can be used to fire weapons to terminate priority targets or quickly gather intelligence that can be immediately updated in Army servers. And the ability to send real-time video and other data directly into a fighter jet cockpit without the need for a server or station could greatly reduce latency to speed up real-time combat orders. Steve Fendley added that, quote, successful operation of the internal weapons release system or function, along with further aerodynamic envelope increases, continues to assert the incredible capability and cost per performance value of the low-cost attritable XQ-58A Valkyrie. He ended by stating that, quote, there is still much to come. High above the blistering Mojave Desert, the largest operational aircraft in the world, with a jaw-dropping wingspan of 385 feet, thundered up to the skies on a mission of paramount importance. Yet, even more critical than the Roc's colossal frame was its cargo. Clamped beneath its massive structure was the Stratolaunch's TA-1 hypersonic test vehicle, a cutting-edge powerhouse poised to redefine the future of American hypersonic technology. For years, the corridors of the Pentagon have buzzed with anxiety. Intelligence reports painted a grim picture. Russia and China potentially outpacing the United States in the hypersonic arms race. Claims surfaced of enemy hypersonic nuclear missiles that could strike with such unfathomable speed that they'd be untouchable by any current American defense system. In the shadow of these chilling assessments, the U.S. military has placed its bets on the Stratolaunch's TA-1. This moment is not just another test flight. It's America's audacious punch back in the face of escalating threats. With top military brass locked in, the inaugural hypersonic flight of the TA-1 may very well be the key to America's military supremacy in the near future. The concern over a potential hypersonic gap between the United States and its geopolitical rivals, Russia and China, has been voiced by several American military experts, politicians, and military officers. This apprehension stems from the perceived advancements in hypersonic technology by Russia and China compared to the US, which many agree seems to be lagging behind when it comes to hypersonic military solutions. Russia has publicized its development of hypersonic weapons, like the Avangard and the Kinzhal. The Avangard is claimed to be capable of reaching speeds above Mach 20, and President Vladimir Putin has touted it as capable of evading American missile defenses. Similarly, China has conducted tests of hypersonic glide vehicles, and in 2021, it reportedly tested a nuclear-capable hypersonic missile that orbited the globe before speeding towards its target, demonstrating advanced maneuvering capabilities that could challenge existing missile defenses. The claims made by Russia and China about their hypersonic prowess are difficult to verify independently. Most information comes from state-controlled sources, which could potentially exaggerate the facts for strategic posturing. However, the tests they have publicized and the reactions from the U.S. military and intelligence communities indicate that these weapons are indeed a significant concern and likely possess some of the claimed capabilities. The U.S. has not publicized possessing weapons with similar features. Several factors contribute to why America might have lagged in hypersonic technology. Initially, the U.S. focused more on other technological areas, like stealth and precision-guided munitions. Furthermore, budget constraints, shifting priorities over the past 2 decades, and technical challenges inherent in hypersonic development, such as material science and propulsion technology, have impacted progress. The potential hypersonic gap presents a grim scenario for U.S. military strategy. Hypersonic weapons can travel with speed and maneuverability that render traditional missile defense systems virtually useless. This could theoretically give adversaries like Russia and China a significant strategic advantage in a conflict, potentially undermining the deterrence that the U.S. relies on. In response to these developments, the U.S. has ramped up its own hypersonic programs. The Defense Department has requested substantial increases in hypersonic research and development. For instance, the fiscal year 2022 budget request included $3.8 billion for hypersonic research, a significant increase from previous years. The U.S. military is developing multiple hypersonic systems, such as the Air-Launched Rapid Response Weapon and the Hawk, short for Hypersonic Air-Breathing Weapon concept. Additionally, the Pentagon is investing in private hypersonic projects that might help the military collect critical data about hypersonic travel. One of those projects is Stratolaunch's TA-1 hypersonic test vehicle. In a historic first for aviation, the air-launched Titan Stratolaunch, birthed by the visionary mind of the late Microsoft co-founder Paul Allen, unleashed a significant breakthrough. Its behemoth Roc airplane, boasting a wingspan of 385 feet, successfully launched a wing test vehicle on its inaugural rocket-powered ascent. Stratolaunch's single-use TA-1 test vehicle blazed a path toward the development of future reusable hypersonic test vehicles, crucial for propelling the U.S. military to new heights in aerial combat. According to Stratolaunch's president and CEO, Zachary Crever, the TA-1 roared into supersonic speeds, flirting with the hypersonic threshold of Mach 5. Crever stated post-flight, quote, "While I can't share the specific altitude and speed TA-1 reached due to proprietary agreements with our customers, we are pleased to share that, in addition to meeting all primary and customer objectives of the flight, we reached high supersonic speeds, approaching Mach 5, and collected a great amount of data at an incredible value to our customers." This landmark test was conducted above the Mojave Air and Spaceport, the home base of the Roc, the world's largest operational aircraft. Designed as a colossal flying launch pad, the Roc is engineered to deploy rocket-powered vehicles like the TA-1 and its successors. The air launch method allows these significant missions to originate from virtually any airport equipped to handle Roc's massive frame. This concept isn't new. It echoes the 2004 launch strategy that clinched the $10 million Ansari X Prize for private spaceflight, with Paul Allen's backing. Founded in 2011 by Allen, Stratolaunch initially aimed to dispatch crewed spaceplanes into orbit. However, following Allen's passing in 2018, ownership switched to Cerberus Capital Management, who relocated the company's headquarters from Seattle to Mojave and pivoted towards advancing hypersonic technology. Roc's maiden test flight was in 2019, and since then, Stratolaunch has been methodically gearing up for this groundbreaking powered flight. The standard mission profile involves carrying the test vehicle beneath the Roc from takeoff, and then releasing it at an altitude exceeding 20,000 feet for its fiery journey through the skies. For the U.S. military, this first flight of the TA-1 is a pivotal moment in its path toward developing advanced hypersonic technology and closing any possible gap that might exist between the U.S. and its superpower rivals across the globe. The Stratolaunch's TA-1 hypersonic test vehicle helps the U.S. Air Force Research Laboratory, or AFRI, by providing a platform to conduct various flight profiles that simulate hypersonic flight conditions. This allows the military to develop and validate hypersonic weapon systems and their countermeasures. The TA-1 vehicle serves as a crucial step toward reusable hypersonic vehicles. Its design allows for carrying out high-speed tests at speeds of Mach 5, offering a rapid, cost-effective, and repeatable testing method. That is the critical difference and what makes the Stratolaunch project so valuable. Each flight attempt might cost several millions of dollars when testing their own hypersonic missile prototypes, and the technology can be lost during the trial. On the other hand, by using a reusable system such as the TA-1, the US military can drastically reduce costs and continue to gather critical data and test internal systems. These tests are essential for refining the technology necessary for future operational hypersonic systems, which are crucial for national defense, given the advanced hypersonic capabilities of other nations like Russia and China. Stratolaunch has contracts with the US military, including a Navy-backed contract for multiple hypersonic flight tests, which supports the development of the Multi-Service Advanced Capability Hypersonic Testbed, or MACH-TB. This program is designed to accelerate the testing and advancement of commercially available hypersonic systems, enhancing the Defense Department's ability to field these advanced technologies. In addition to providing a platform for these tests, the data and insights gained from the TA-1 flights are invaluable for improving operational strategies and technological frameworks within the hypersonic domain, further underlining the strategic importance of such test vehicles in national defense technology development. Although the TA-1 test flight did not hit Mach 5 speeds, and thus did not officially reach hypersonic status, it signaled a significant leap toward the operational goals of the program. The flight also debuted the in-flight performance of the Ursa Major's Hadley rocket engine, an experimental powerhouse designed for space launch vehicles, named after the Hadley Rifle, the lunar geological formation explored by the Apollo 15 crew. The main objectives were clear: execute a safe release of TA-1, ignite the engine, achieve a steady climb in altitude, and ensure a controlled splashdown in the Pacific Ocean. This test is a cornerstone for the development of TA-2, aimed to be Stratolaunch's first fully reusable hypersonic vehicle, a game-changer poised to narrow the American gap in hypersonic technologies. Stratolaunch President and CEO Krever expressed his forward-looking perspective, quote, "Our goal with this flight was to continue our risk reduction approach for the TA-2's first reusable flight. We are excited to review the data from today's test and use it to inform our next steps toward TA-2's maiden flight later this year." The US military plans to harness data from Stratolaunch's flight tests to advance hypersonic weapon systems and countermeasures in response to adversaries' swift development of similar technologies. Russia, for example, has already employed air-launched hypersonic Kinzhal missiles in its conflict with Ukraine. Despite early reports questioning the weapon's effectiveness, it remains significantly more advanced than American capabilities in the realm of hypersonic missiles. As Stratolaunch propels forward, work is underway on TA-3, the next fully reusable hypersonic vehicle in its Talon A lineup. Additionally, the company has commenced modifications on the Spirit of Mojave, a converted Boeing 747-400 acquired from Virgin Orbit during its bankruptcy. This aircraft is set to become Stratolaunch's second air launch platform, supplementing the colossal Roc. Stratolaunch's journey through the development of hypersonic technologies marks a pivotal chapter in American aviation and military prowess. Though the TA-1 did not reach hypersonic speeds, its successful test flights and the introduction of the powerful Hadley rocket engine demonstrate significant strides toward operational readiness and technological advancement. With each test, Stratolaunch not only hones its craft, but also contributes vital data to the US military's ongoing efforts to match and surpass global competitors in hypersonic warfare. Under the watchful eye of the Defense Advanced Research Projects Agency, an extraordinary creation has been taking shape. A remarkable aircraft that emerged as the culmination of groundbreaking innovation, the new unmanned aerial vehicle, designated X-65, after a long line of iconic experimental aircraft, will ditch all traditional control surfaces that had limited aerodynamics for generations. Instead, it will find control from within. The X-65 will feature active flow control rather than passive exterior moving controls, and redefine aviation with compressed air nozzles to execute maneuvers, subverting long-held tenets of aviation and aerodynamics. The advances expected from this project seem taken out of a science fiction story. They could usher in a new era of reduced radar cross-sections, increased maneuverability, and unparalleled efficiency in flight. Besides drones, this technology would make fighter aircraft more agile and commercial passenger airliners more environmentally friendly. As of 2023, an aviation giant has just taken up the task of bringing this outstanding piece of engineering to life. DARPA known for its avant-garde exploration of advanced technologies on behalf of the Pentagon, recently unveiled a revolutionary drone technology demonstrator. The pioneering project aimed to test the capabilities of active flow control systems, or AFC. Such systems promised to enhance fuel efficiency while reducing radar signatures, all achieved by allowing for a more streamlined and aerodynamic aircraft configuration. The experimental nature of this uncrewed marvel became evident as it discarded the conventional flight controls that had long governed aerodynamic design. Instead, banks of compressed air nozzles were employed to execute awe-inspiring maneuvers without the need for traditional exterior moving flight controls like hinged flaps, rudders, ailerons, elevators, and spoilers. These control surfaces, although effective throughout the history of aviation, brought along the burden of added weight and intricate complexities. Capturing the imagination of aviation enthusiasts and experts alike, DARPA took to its social media platforms to proudly announce the coveted X designation bestowed upon this leading-edge creation. This significant milestone came just shy of 5 months after DARPA's selection of Aurora Flight Sciences, a subsidiary of Boeing, to embark on the detailed design phase of the Control of Revolutionary Aircraft with Novel Effectors program, or CRANE. DARPA chose Aurora Flight Sciences to proceed with the CRANE program to create an aircraft that can fly without traditional moving flight controls on its wings and tail. In turn, Aurora successfully completed Phase 1, which involved designing a testbed aircraft that utilized AFC in a wind tunnel. Phase 1 involved wind tunnel testing on a scaled-down version of the X-65 prototype, using compressed air blasting and suctioning nozzle arrays on the wing's upper surface. The next phase aims to test the technology at mission-relevant scale and Mach numbers. Phase 2 will not only assess the craft's supersonic flight capabilities, but will also focus on the detailed design and development of flight software and controls, leading to a critical design review of an X-plane demonstrator. The contract also includes a Phase 3 option, in which DARPA plans to fly a 7,000-pound X-plane that addresses the main technical challenges of incorporating AFC into a full-scale aircraft and relying on it for controlled flight. The demonstrator aircraft will feature modular wing configurations to facilitate the integration of advanced technologies for future flight testing. The company is confident in completing the AFC-based demonstration aircraft's design and flight testing, which would become a national test asset beyond the CRANE program. However, the current aircraft under construction is expected to achieve a maximum speed of Mach 0.7, barely 537 miles per hour, and it is not scheduled for testing until 2025. DARPA recently unveiled art concepts for the X-65. Interestingly, commentators have pointed out that, as described by DARPA, the aircraft resembles the fictional X-Wing starfighter from Star Wars when viewed from the front. This is due to its canted double wings, although the similarity is less apparent from other angles. The designation of the X-65 may even be a nod to the T-65 model of the X-Wing in Star Wars lore. Unlike traditional aircraft, the experimental type has a revolutionary active flow control system that promises improved maneuverability and control. By eliminating traditional jointed surfaces, this innovative design could enhance flight performance while reducing costs and wear and tear. It could also, theoretically, improve the aircraft's stealth capabilities. The AFC system offers numerous advantages. It eliminates the need for moving control surfaces, resulting in reduced drag and improved flight at high angles of attack. Based on the available pictures, it appears that the X-65 will be powered by a single jet engine with an intake located under the belly. Additionally, there seems to be an upper fuselage intake and exhaust, potentially used to generate compressed air for use in the 14 nozzle banks around the airframe. On the other hand, DARPA emphasized the inclusion of modular wing configurations, allowing for the integration of advanced technologies in future flight testing. The X-65's design will be highly modular, enabling the swapping of different wings with varying degrees of sweep and different types of AFC effectuators, including those developed by other companies. The X-65 represents a groundbreaking leap in flight control technology, capturing the imagination of aviation enthusiasts and showcasing the exciting possibilities for the future of flight. Active flow control is a technique used in aircraft to manipulate the airflow and improve performance. Unlike passive features, such as vortex generators, that affect airflow permanently, AFC utilizes nozzles to release jets of air that dynamically alter the pressure of the boundary air around the craft. Besides compressed air, Other methods of manipulating the airflow, like plasma effectors, are being studied. Its main objective, eliminating surfaces on the aircraft that cause drag and increase radar signature, is particularly crucial for military aircraft, including drones. Operating in contested airspace, monitored by advanced radar-guided missile defenses, requires stealth. Reducing the radar cross-section is essential, even for non-combat aircraft, like tankers and transports. The B-2 stealth bombers address these challenges through complex flight control systems that manipulate flaps for stability and turning while discarding the tail fin and rudder control surface. However, even these reduced movements increase the radar cross-section. AFC has the potential to render this vulnerability unnecessary in future aircraft. Moreover, reducing drag is significant for civilian aircraft operators as well. Improved fuel efficiency and extended range are highly desirable outcomes. Airlines can reduce pollution and save substantial fuel costs with even a slight increase in fuel efficiency. Likewise, military aircraft, including jets, drones, and missiles, can travel farther with the same fuel load. Eventually, AFC nozzle arrays are expected to become lighter, less complex, and more fuel efficient than traditional moving control surfaces. During NATO's 2018 tests, drones equipped with AFC responded more aggressively than anticipated, showcasing their agility. If these systems can deliver high performance while maintaining low weight, complexity, and radar cross-section, they could be attractive for various aircraft, including modern jet fighters. Projects like Crane are working toward making AFC technology affordable and practical for widespread adoption. The program's manager, Richard Lesian, stated that the X-65 would probably benefit a variety of other airflow control experiments, hypothetically including those of BAE Systems' Magma drone. In the bustling Atlanta, Georgia facility of the pioneering aerospace startup Hermeus Corporation, a crack team of scientists and engineers, armed with a vast array of high-performance power tools, make all-important tweaks to their revolutionary new aircraft, the Quarter Horse. Having already developed the turbine-based combined-cycle Chimera engine, a machine as innovative as it is powerful, Hermeus is now busy creating the perfect vehicle to put its abilities to the test. A sleek, sophisticated jet of the future, the Quarter Horse is being built with one clear objective: speed. As the prototypes zoom through the clouds at hypersonic velocities, pushing the limits of aviation technology, the Quarter Horse keeps its eye on the grand prize, the airspeed record set by the Blackbird SR-71 in 1976. Nearly 50 years later, the Blackbird remains number one, with no aircraft able to better its impressive feat. Yet, as the Quarter Horse project steams ahead, it seems there may finally be a challenger for the Blackbird's crown. Hermeus Corporation began its journey in 2018. Its name was inspired by Hermes, the Greek god of speed and travel, famous for his winged sandals that gave him the gift of rapid flight. Apart from a combined CV that includes the likes of SpaceX, Northrop Grumman, and Blue Origin, the company's four founders, CEO AJ Piplica, COO Skylar Shuford, CTO Glenn Case, and CPO Mike Smeda, had all previously worked at aerospace firm Generation Orbit Launch Services, where they'd been instrumental in the early development of the X-60A. This ongoing project for the Air Force Research Laboratory hopes to create a hypersonic aircraft capable of speeds between Mach 5 and Mach 8. While Generation Orbit's X-60A project is more focused on governmental and military applications, Hermeus was founded with a different type of hypersonic aircraft in mind, one which would radically transform commercial air travel by significantly reducing travel times, enabling passengers to traverse vast distances at unprecedented speeds. In its early days, Hermeus quickly garnered attention and support from the investment community, securing a seed investment round led by Khosla Ventures on May 13, 2019. This initial vote of confidence was not only a sign of the startup's potential and the compelling nature of its mission, but was crucial in propelling the company forward in its ambitious goals. The company's pursuit of high-speed aviation is encapsulated in its flagship program, the Quarter Horse, which is the inaugural step in Hermeus' roadmap to achieving hypersonic flight. The Quarter Horse has been designed as an unmanned autonomous demonstration aircraft with a futuristic, streamlined shape and a compact length at under 40 feet to provide excellent aerodynamic efficiency and maneuverability. The main objectives of the project are twofold. Firstly, it aims to prove the in-flight capabilities of Hermeus's cutting-edge Chimera engine. Designed, built, and tested in 21 months at a cost of $18 million, the Chimera is a turbine-based combined cycle, or TBCC engine, which combines repurposed GE J85 turbofan jet engines with proprietary ramjet technology. This will allow the quarter horse to take off from a regular runway in turbojet mode before switching to ramjet in order to accelerate up to high Mach speeds. In August 2020, Hermeus claimed that during testing in a wind tunnel simulating flight at 65,000 feet, a subscale prototype of the Chimera engine managed an already impressive speed of Mach 3.3, while the full-scale version is believed to be capable of about 10 times the prototype's thrust. The team at Hermeus hopes this will then allow them to reach their second objective, to break the airspeed record. The current record was set on July 28, 1976, by a Lockheed Martin SR-71 Blackbird reconnaissance aircraft, piloted by Captain Eldon W. Jors, with Reconnaissance Systems Officer Major George T. Morgan, Jr., at a speed of 1,905.81 knots, equivalent to 2,193.2 miles per hour, or Mach 3.3. Remarkably, despite significant advancements in other areas of aviation technology, this record has now remained unchallenged for 48 years, but Hermeus plans to change this with the quarter horse. While the quarter horse had originally been conceived of with the transformation of commercial flight in mind, it didn't take long for the U.S. Air Force to recognize the program's potential for military applications as well, awarding Hermeus a $1.5 million contract for the development of the quarter horse in August 2020. This was followed in July 2021 by a more substantial Air Force investment of a further $60 million. Of the decision to offer such a sizable financial contribution to the project, Air Force Research Laboratory Commander Major General Heather Pringle commented, quote, "When it comes to technology, we often hear the term game-changing. However, hypersonic aircraft and propulsion systems are truly game-changing and will revolutionize how we travel, just as automobiles did in the last century. We are excited to be part of this effort and to help propel this important technology." Notably, the investment received joint funding from the Air Force Research Laboratory, several venture capital entities, and the Air Force Lifecycle Management Center's Presidential and Executive Airlift Directorate. The quarter horse's promise of extremely fast air travel has led it to be looked upon as a possible future presidential transport, with Hermeus unveiling a full-scale Air Force One mock-up of the aircraft in November 2021. The company's aspirations took another leap forward in March 2022 by successfully raising a $100 million Series B investment round. This round was led by entrepreneur Sam Altman, also seeing contributions from other notable investors such as Peter Thiel's Founders Fund and In-Q-Tel, as well as continued support from existing investors like Khosla Ventures, Canaan Partners, and Bling Capital. Just 2 months later, the project received another boost with the announcement of a strategic investment from Raytheon Technologies through its then newly established venture capital group, RTX Ventures. This substantial influx of funds was a testament to the growing confidence in Hermeus's potential to redefine aviation. Rather than attempting to deliver a single prototype capable of attaining all the program's goals, the quarter horse is following an iterative design process, which will result in the construction of 4 different vehicles, each one representing a distinct phase of the project's development, and possessing individual objectives which become more ambitious with each new version of the aircraft. Hermeus has stated that the reasoning behind this rapid, hardware-intensive method is to de-risk future vehicles and accelerate the learning process. The project began with developing the company's first fully integrated vehicle, the Quarter Horse Mark 0. While this initial prototype is not airborne itself, it has served as a dynamic Iron Bird, a comprehensive testbed for all major aircraft subsystems, such as electrical, hydraulic, pneumatic, avionics, steering, and propulsion components, allowing them to be rigorously evaluated in a real-world environment. Ground testing was completed by early January 2024, while at the same time, work was already underway on Quarter Horse Mark 1. Set for completion later in 2024, this vehicle will be flight-capable, with the technical aim of successfully performing remote takeoff and landing. Once this goal has been reached, the Mark II will take on the challenge of breaking the sound barrier and establishing autonomous supersonic flight below Mach 3. The final prototype, Mark III, is intended to be the one to demonstrate the turbojet to ramjet transition of the cutting-edge Chimera TBCC engine and complete the project's key objective of breaking the SR-71's long-standing airspeed record. Hermes has stated that the Quarter Horse is merely the first in a series of groundbreaking aircraft that it plans to unveil in the coming years, all focused on a hypersonic flight. According to official statements, it will be followed by the Dark Horse, a multi-mission uncrewed aerial system designed for defense and national security missions. The Dark Horse will be propelled by a different version of the Chimera, which integrates the Pratt & Whitney F-100 turbofan engine, making it significantly more potent than its predecessor. This, in turn, will pave the way for the Halcyon, a passenger aircraft designed to revolutionize transoceanic travel by flying over 125 routes at hypersonic speeds, which is 5 times faster than current commercial aircraft. This could reduce a New York to London trip to just 90 minutes, significantly saving time for over 500,000 business-class passengers annually on this route alone. The potential social and economic impact of such accelerated transportation is vast, with the possibility of adding over $4 trillion to the global GDP annually through faster commerce and cultural exchange. While it remains to be seen how long it will take for Hermes to develop these aircraft and exactly how fast they will be able to travel, the world would be tracking their project's progress with bated breath. As the company's dedicated team of experts continue to make advances with the hotly anticipated Quarter Horse program, it seems increasingly likely that a new era of aviation will soon be upon us.